Okay, so the first lesson in this module is taking a square root and simplifying it down. So I understand that some specific numbers you can take the square root of and you get a nice whole number answer, and you can do that on your calculator. You can also take the not so nice numbers and put them on your calculator and get a decimal out. But sometimes it's important for us to have an exact answer, so that's why we need to learn how to simplify these radicals. So essentially what we're going to do is we are going to take numbers and break them down into perfect squares, and then take the square root of the perfect squares, leave the other ones alone. So you can see here, this problem here, and it doesn't actually show it, but this problem started out as square root of 45. Okay, so square root of 45. And then the person doing this problem recognized, hey, I can break 45 down into 9 times 5. So I take square root of 45, and I know that square root of 45 can become square root of 9 times square root of 5. The square root of 9 is convenient because you guys hopefully all know that the square root of 9 is 3. So that's where I get my 3 out here out front. And then the square root of 5 I cannot take the square root of, so it's just going to stay inside the square root. That is the most simplified answer. Okay? So essentially what we're doing is we're taking numbers, breaking them down, breaking out the perfect squares out of them, and leaving the rest alone. So let's look at number 1. Okay? Actually, before we look at number 1, or kind of in the process of us looking at number 1, we need to know our perfect squares. So let's make a list of our perfect squares up here. Okay. So 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. Let's just stop there, okay? So these are the numbers that we're looking to divide out. And if you don't divide the biggest one out first, it's not that big of a deal. We can always take another one out. So let's look at 24. So I want to think, do any of my numbers that I have up here as perfect squares divide out of 24? I know 4 does. So I'm going to say, okay, 24 divides into square root of 4 and square root of 6. Because 6 times 4 is 24. Square root of 4 I know is 2. So that's nice. And then you want to think, so this is one of my perfect squares, right? Does square root of 6 come out as anything? Can I divide 4 or any other number out of 6, which I can't. So I know square root of 6 is done. So square root of 6 is done. So I have, actually I don't want to rewrite it. So 2 is my only square root, or excuse me, 2 is my only perfect square. 6 is still in the square root, so that becomes 2 radical 6. Okay, so whatever whole numbers you can bring out, that's perfect. Those go outside. Whatever you have to leave inside the square root, you leave inside the square root. Okay? All right, let's look at number 2. Okay, so I want to think, I guess let me leave it zoomed out here a little bit so I can think about dividing numbers into 162. So just take a shot in the dark. So let's just try 16. So 16. So I have 162 divided by 16. That didn't work, right? You could try 25. I don't think 25 is going to work. Let's try 9. So 162 divided by 9. So 9 times 18 is going to work. Okay, so square root of 62, or excuse me, 162 is going to become square root of 9 times square root of 18. Okay, let's leave the variables. Sorry guys, my stylus is getting kind of sticky and nasty here. Let me try to go with my finger, okay? So let me zoom in here. So it's going to become the square root of 9 times the square root of 18. Okay, I know the square root of 9 becomes 3, so there's a whole number. And then I think, okay, are there any perfect squares that I can divide out of 18? And I realize I can divide 9 out again. So it's going to become the square root of 9 times the square root of 2. And again, I know 9 becomes 3, so there's another whole number that came out. My square root of 2 is finished. Okay, so that's going to be part of that because I can't divide anything else out of 2. So, now let's look at the variable part. So the variable part, remember, I want an even number of variables. So if I have 6 G's, that's like 3 pairs of G's. Because remember, when I'm looking here, perfect squares, as far as the variables go, it's any even number. So I know the square root of G squared becomes G to the third. So that part's going to be out there too. Okay, so whole numbers, the parts that are not in radicals are going to be this 3, and G to the third. So I'm multiplying all those together. So 3 times 3 is 9. I bring my G to the third along, and then my part that's still stuck inside the radical is 2, not 3, sorry. 2. So that's my final answer, 9G to the third, radical 2. All right, let's go ahead and do another one. Actually, I'm going to let you guys go ahead and do them. So go ahead and pause the video. Ooh, on number 3, the radical is supposed to be over the 48. All right, let's fix this up here. So the negative is supposed to be outside, and it's supposed to be radical 48. Sorry, the part got messed up there. Okay, so go ahead and pause the video, do 3 and 4, and then you can unpause the video when you're ready for me. Okay, so looking at number 3, so let's think about 48. So I think 48 is divisible by 16. So let's see, 48 divided by 16 is 16 and 3, so that worked out well. One thing I want to talk about with this problem, anytime you have anything that is sitting out front, that needs to be circled because it needs to be part of your final answer, okay? So 48 we said is square root of 16 times square root of 3. We know the square root of 16 is 4. That's good. And I know I cannot divide anything else out of square root of 3. So I have a negative, a 4, and a square root of 3. So I'm going to bring that all together. Remember, the negative and 4 are outside, so negative 4 is outside, 3 is inside. So anything outside all gets multiplied together, anything inside all gets multiplied together. All right, let's look at number 4. Whoa, too far. Okay, so right off the bat, I see that I have a negative outside, so I'm going to circle that. 512, let's think about that. Let's see if it's divisible by 36. It is not. Let's see if it's divisible by 49. Let's try to get a big number here. It is not. What's after 49? 64. 512 divided by 64. Ooh, I got a good one. 64 and 8. Okay, so 512, I can break into square root of 64 times the square root of 8. Okay, so square root of 64 I know is 8, so that one's done. 8, think about, can I divide any perfect squares out of it, which I can. I can divide square root of 4 out, right? So square root of 4 comes out. So 4 times 2 is 8, and then I know square root of 4 is 2. There's another whole number. I can't divide anything else out of 2, so square root of 2 has to stay. So I'm done with my numbers. Let's think about variables. So remember, the only way a variable can come out of the square root is in a pair. So if I have an odd number of h's, I'm going to have to break those apart. So this h is going to have to become square root of h to the 6th times square root of h. Okay, so square root of h to the 6th, once I have an even number, then I can say, okay, half of that's going to come out. So h to the third comes out, and then this h is going to have to stay inside. So outside stuff would be this negative, this 8, this 2, and this h to the third. So I want to bring my negative down. 8 times 2 is 16. I bring my h to the third as well, so I'm done, 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 done. And then it looks like the stuff that's inside the radical is 2 and h. So radical 2h. And there's my final answer.